Good afternoon. I am a faculty of Pillai HSC College of Arts, Science and Commerce, Rasaini. This topic is for SY BSc students, Physics paper 3rd, and the topic is optical fiber. After the completion of the topic, here a student is supposed to understand the structure, construction, working principle, and the propagation of a light signal through the optical fiber. This optical fiber we have seen in our day-to-day life. It has many advantages over the metallic cable. We will first see the advantages over the metallic cable. Earlier, for the data transmission, copper cables were widely used, and as you are aware, all the metallic cables are nowadays replaced by the fiber optics. This is because the fiber optic offers faster speed with the less attenuation of the signal. Second point is that it offers larger bandwidth. And what is the importance of a larger bandwidth? It is having a greater information carrying capacity. One of the most advantage of an optical fiber over the metallic cable is the immunization of optical fiber to the electromagnetic interference. And because of this property, the optical fibers are used in defense and banking sector. This makes the optical fiber that has replaced the metallic cables in almost all the telecommunication and the data communication. So we have learned the advantages of an optical fiber over the metallic cables and the replacement of a copper wire by the optical fiber. Now, what is an optical fiber? It is a technology that uses the light signal instead of the electrical signal to transmit data from one end to another. Now let's see the construction, what it is made up of. The optical fiber, it consists of number of layers. The central axis you are seeing, it is the axis of the fiber. It is made up of a thin, transparent, flexible material. The material can be a silica, it can be a glass, it can be a plastic, and this is called as a core. And this material will have a refractive index whose value is high. This innermost layer, it is surrounded by one more layer of a transparent material. It is called as a cladding. It is to remember that the refractive index of the cladding is the value of the refractive index. It should be less than the refractive index of a core for the proper functioning of the optical fiber. Now, as the core and the cladding are thin, flexible, transparent material, to protect the whole structure, it is again surrounded by a strong or a wide region of plastic, which is called as a buffer or jacket. The jacket prevents the optical fiber from the external environmental conditions and prevents it from the damage. So the optical fiber we are seeing, it is made up of 3 different regions. The innermost region is called as the core. The core is surrounded by a cladding and both of them are surrounded by a jacket. For a proper functioning of optical fiber, N1 should always be greater than N2, where N represents the refractive index. Now these regions we have seen, the core, cladding and the jacket, the dimensions vary depending upon the type of the optical fiber. For the core, the dimension varies from 5 to 135 micrometer. For the cladding, the dimension varies from 50 to 500 micrometer. The variation depends upon the type of the optical fiber we are using. And the jacket, the dimension is maximum and it is from 500 to 1000 micrometer. So depending upon the type of the optical fiber, the dimension varies. As a result, the application of the optical fiber also varies. The last thing that we are going to study, it is the types of the optical fiber, and the types are categorized into 3 types based on the material that we use depending upon the refractive index profile, and the last one is the mode of propagation. Now based on the material, it is classified as the glass fiber or a plastic fiber. If it is plastic, then it is the polymethyl acrylate is used. Depending upon the material, it is of the 2 types, a glass optical fiber or a plastic optical fiber. If we categorize it according to the refractive index profile, then again it is of 2 types. It is the step index optical fiber and graded index optical fiber. Short form, it is written as GRIN, graded index optical fiber. If we categorize it according to the modes of the propagation, then again it is further categorized into the 2 types. It is the single mode optical fiber, where only one mode of light is allowed to pass through it, and the another one is multi-mode, where number of light waves are allowed to propagate through it. Single mode optical fiber is further categorized as a single mode step index optical fiber, and there is no other categorization, only one type is there. In multi-mode there are 2 types, multi-mode step index optical fiber and multi-mode graded index optical fiber. For single mode, the dimensions are, for core it is 5 to 10 micrometer, for cladding it is 100 to 150 micrometer. For multi-mode, the dimensions are 50 to 135 micrometer, and for cladding it is 200 to 500 micrometer. So we have seen the types of the optical fiber, which are categorized into different types depending upon the material used, refractive index profile and the mode of the propagation. And here the dimensions for the single mode and the multi-mode for the core and cladding are mentioned. In single mode, you see that the dimension of the core is very less, therefore only single wave can propagate through it, and it propagates along the fiber axis. In multi-mode, if we see the core dimension, it is much higher than the dimension of the single mode, and therefore many more light waves can propagate through it, and the light will follow either a zigzag path or a sinusoidal wave.